So our next lab is pretty straightforward. There's going to be some really important details we need to make sure we pay attention to in the lab to make sure that things work correctly, not only for us, but for the labs that come after us. And then the post-lab is pretty straightforward as well. It's just writing equations for things that happen, so no math with this lab. So what we're looking at in this lab is asking the question, if we have two aqueous solutions, and I've just indicated what they are generically here, that we mix together, what happens when we mix them together? And there's a couple of possibilities of things that we might be observing. I shouldn't say a couple, there's a lot of possibilities for what we might observe. But one of the things that it's important to note is the solutions that we start with, by having this AQ term here, indicates that these solutions have components in them that have not only dissolved, but have dissociated if they are ionic salts. So let's kind of break that apart a little bit further here. If something dissolves, it means it's surrounded by water and we don't see it in solution anymore. Both ionic and covalent compounds can dissolve. Classic examples are sugar is a covalent compound and salt is an ionic compound. But salts have a special property that they also dissociate, or they break apart into ions in solution. So ionic compounds as well as acidic compounds dissociate. And a term that I don't have on this slide here, but just as an important term to think about, solutions that dissolve but do not dissociate, we refer to as non-electrolytes. Solutions that dissociate or produce ions in solution, we call electrolytes. Okay, so part of this lab is asking our question, who is in solution and what's the possible chemistry that could happen? So when we think about, for this generic example, who is in solution here, we can see that we're going to have A plus cations and B minus anions, and then C plus cations and D 2 minus anions. And right now, I'm not too worried about the stoichiometry or the number of ions that I have for each, but when all of these are in solution, remember that we can have new interactions form with cations and other anions. We're never going to have two cations interact with one another, and we're not going to have two anions interact with one another. So we ask the question, with these new possible pairings, do we do some interesting chemistry? Okay, so highlighting, you're not going to see like charges interact. So that's going to help us start to begin to answer this question of what are the possible new things that we could be making in solution. And sometimes there's not going to be new interactions that happen. Actually, a lot of the solutions that you're going to be mixing together, the new partners do not have any interest in doing chemistry, forming a precipitate, doing acid-base chemistry, generating some bubbles, right? We're not going to necessarily see those. So don't worry if a lot of your reactions seem to indicate no reaction. So again, what we're going to be able to think about here is, of the new possible pairings, are they going to be aqueous, maybe meaning there was no chemistry that happened because those ions are still in solution? Did we form a solid, indicating that we had a precipitation reaction? Your observations are going to be what determine what we put there. Good news is that there are rules that we can follow and a table that's provided for you to help you rationalize and even predict what you might see as you mix different solutions together. So these are what we call solubility rules for ionic compounds. And we'll go through this more in class as we look at this, but you can see that there's certain pieces that if they are part of a salt, that salt is always going to be soluble, with a few notable exceptions. Then we're going to have things that are almost always insoluble. And here again are a list of exceptions. So as you begin to learn this and begin to learn how to predict precipitation reactions, this information is going to be provided for you, but you just need to know how to use this table to solve that question. All right, so let's get into a little bit of the logistics. Dr. Brown has a great experimental video where you can actually see what this setup looks like. I've kind of tried to recreate it here just in kind of a virtual space. But the main thing, and I'll highlight this several times here, is you will only have, your data is only going to be good as kind of the solutions that we have. So we really want to make sure that we're doing our best to not cross-contaminate solutions, because not only will that affect your results, but if those contaminated solutions are used by the next student, they're not going to get good results either. So when you're doing these experiments, be very careful, and that's why you can work with your partner to make sure that you don't sort of cross-contaminate solutions. So I'll talk about a couple of tips to help avoid that. So 2 parts to this experiment. Part 1 is kind of the larger piece, if you will, because we've got 20 different reactions we're going to be investigating. And really what you're going to do is set up 20 test tubes that essentially mirror what this matrix is. So 20 test tubes that you're going to have in a test tube rack, and set them up as 4 columns and then 5 rows. So you can just match what goes into each test tube. So again, each test tube for a reaction is going to have 5 to 10 drops of each solution as indicated. Okay, now this is where it's really important. When you're adding those drops in, do your best, like you're playing the game of operation, to just drop those drops in. Don't have your eyedropper kind of touch the side of your test tube, especially if you've already added another component in there, because that's going to cross-contaminate the end of that dropper. So really do your best to transfer solutions in to try to avoid cross-contamination. Okay, so each of these is going to represent one mixture of 2 solutions being mixed. If you'd like, one of the things that you can do, and I'll demonstrate this when we're in lab, if you hold the test tube, you can just kind of like hold it firmly up on top, and you can finger flick it as a way to help mix the materials that are in there. And that's going to be a good way for you to say, well, is there a precipitate there? Or if I finger flick it, does it go away? Okay. Anything that we generate in this matrix of 20 different test tubes, we want to make sure that this goes into the proper waste container. These solutions cannot go down the drain. They have some metals in them that would just not be good to get out into the environment. Okay, so important things to highlight here. You want to make sure that you make observations for each of these reactions. Do you form a precipitate? Do you see bubbles that are evolved? Might not notice with those small amounts whether or not any heat is kind of evolved, but see if that's something that you feel like you noticed. Scientists make observations, so we want to be making good observations here. And to highlight, there is one tube here when you're mixing the nickel nitrate solution with sodium hydroxide. This is going to be one that you're going to save for step 2, for part 2. Okay, and there's going to be an opportunity to centrifuge and then get rid of the liquid on top. So Dr. Brown's video kind of goes through a great demonstration of how to use the centrifuge. Okay, at the end of the day, this is a hint. We're going to see a precipitate with this reaction. We want to save that precipitate, and then we're going to do an experiment in part 2 with that precipitate. Okay, so part 2 only has 6 tubes. We want to make sure we know exactly what's happening with those 6 tubes. So 6 tubes, but one of them is left over from part 1, and then there's going to be 5 that are brand new tubes. Now, one thing to highlight, your tubes don't need to be dried out in order for you to start, but they do need to be rinsed out fairly well. So just make sure that your tubes are rinsed out well before you start your experiment, but they do not need to be dry. Okay. So once we're ready to do this first set of experiments, what we're really doing is we're taking 2 solids and we're adding an acid to them to see what happens. So there's going to be some calcium carbonate. You'll use a pea-sized amount of that to put in test tube number 1. Remember, test tube number 2 already has a precipitate in the bottom of it. So to each of these tubes, you're going to add hydrochloric acid per the directions that are in your lab manual and make observations. See what happened. Okay? Special note here that because we have a metal here with nickel, with this one we do want to make sure that this guy goes to waste. I'll remind you of that at the end again here. All right, so for tubes 3 through 6, what you're really going to be doing is adding some of this solution. Here we've got 2 different acids, hydrochloric acid and then acetic acid, and then 2 different bases. And then you're going to be using litmus paper, which will tell us whether the solution is acidic or basic. So you're just going to be taking a little bit and dropping it on the litmus paper and seeing what it looks like. You can actually take and dip a little bit of the litmus paper in there too and just kind of see what color it changes. So that again is just an observation that you're going to be writing here. Now the last part down here is actually going to use these solutions. So you're going to take these solutions and you're actually going to mix them together. So tubes 3 and 5, you're going to mix them together. Tubes 4 and 6, you're going to mix them together. But before you do that, make sure that you have a thermometer inside to measure the temperature before you mix them and then after you mix them, because that's the important piece of information here, is asking the question, do we evolve heat when we mix these solutions together? Okay, reminding us here that 5 of these 6 solutions are actually okay to go down the drain, but this solution that we had, it's going to be in test tube number 2 that had our nickel precipitate from part 1. That solution has to go into the proper waste container. Okay, most of the post-lab here is just going to be you picking and writing balanced molecular, total ionic, and net ionic equations for experiments where something happened, okay? So there'll be an opportunity to practice more of that and discuss more in class, but that's going to be our lab here on investigating kind of precipitate formation.